So in this video, we are seeing from chapter 1 number systems exercise 1.1. So we'll start solving the questions mentioned in exercise 1.1. So the first question is, let's read the first question. Is 0 a rational number? Can you write it in the form p by q, where p and q are integers and q is not equal to 0? So we have to find whether 0 is a rational number or not. We all know that this is the definition of a rational number. If any number can be represented in the form of p by q, where p and q are integers and q is not equal to 0, then that is a rational number. In fact, that's the very definition of rational number. I'm just going to make a note of that. This is okay. This thing here is in fact the definition. Okay, it's the definition of rational numbers. Rational numbers. Okay, so we know that. So let me take this number 0 here. Okay, so this is my number 0. Now if I write 0 in the form of 0 divided by 1, okay, so any number divisible divided by 1 is the same number. We know this property. So 5 by 1 is equal to 5, or minus 3 divided by 1 is equal to minus 3, same. Okay, similarly 0 divided by 1 is going to be 0 itself. So if I can write 0 in the form of 0 by 1, then in that case, okay, let's expand this. In that case, 0 becomes my p, okay, and 1 becomes my q. This is of the form p by q. And p can be any integer, yes. Q can be any integer other than 0, yes. So I have successfully represented 0 in the form of p by q, 0 by 1, which is a rational number. Thus, the answer to this question is 0 a rational number? The answer is going to be yes. Yes, 0 is a rational number, and we can write it in the form of p by q, which is basically 0 divided by 1. So that is how that is the answer to our first question from exercise 1.1. Now let's go to second questions. So I'm going to remove all these questions now. Now the second question is, find 6 rational numbers. Okay, what I'll do is I'll just move this a little bit below so that you just see the second question. Okay, now the second question reads, find 6 rational numbers between 3 and 4. So between 3 and 4 we have to find 6 rational numbers. So let me first erase this. Okay, now so let me write down. So we have to find 6 rational numbers between 3 and 4. Okay, what is this? Let me remove this. So this is my question. Find 6 rational numbers between 3 and 4. So let me note down my numbers here. This is 3 and this is 4. Both of them are whole numbers. They are represented in the form of whole numbers. We know how we can represent them in the form of rational number. We have to just divide by 1. So 3 divided by 1 and 4 divided by 1 is the representation, rational number representation of the given numbers 3 and 4. Now what I'm going to do is I'm going to multiply. Okay, I'm going to multiply both numerator and denominator by 10. So I'm going to get 30. Let me scroll down. I'm going to get 30 divided by 10. And I'm going to do the same operation here. I'm going to multiply both the numerator and denominator by 10. So I'm going to get 40 divided by 10. Okay. So we know that these both representations are called as equivalent rational numbers. Okay, because we multiply both numerator and denominator by 10. So 3 by 1 and 30 by 10 are equivalent rational numbers. Similarly, 4 by 1 and 40 by 10 are equivalent rational numbers. This is a very important term. Let me in fact make a note of it here. This term, okay, it's called equivalent. Okay, sorry. This term, yes, this is called equivalent. Okay, equivalent rational numbers. Okay, these are called equivalent rational numbers. So now once we have equivalent rational numbers 30 by 10 and 40 by 10, we just have to list down the other rational numbers between them. So which are basically 31 by 10, 32 by 10, then we have 33 by 10, dot 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 dot, we have 39 by 10, and finally we have 40 by 10. So this becomes a set of rational numbers that lies between 40 by 10 and 30 by 10, and that is exactly what the question asks. We have to find any 6 rational numbers between 3 and 4. So 3 and 4 were converted to 3 by 1 and 4 by 1. Then they were again converted into their equivalent rational numbers 30 by 10, 40 by 10, and we can pick out any 6 rational numbers these that lie between 3 and 4. So that is our answer to question number 2. Now let's go to question number 3. Question number 3 is exactly similar as question number 2. We have to find 5 rational numbers between 3 by 5 and 4 by 5. So very quickly, let's do the same procedure. Okay, so the rational numbers given to us are 3 by 5 and 4 by 5. Okay, let's convert them into their equivalent. So I'm going to multiply by 10. So here also I am going to multiply by 10. So this is going to be 30 by 50. Okay, let me use a different color. Yes, so this is going to be 30 by 50, and this is going to be 40 by 50. Okay, and again let's make a note here. This is called as equivalent rational numbers. Very important. Equivalent rational numbers. Okay, and now once we have got their equivalent forms 30 by 40 and 40 by 50, all we have to do is list down the rational numbers that lies between them. So let's zoom in. Okay, so that's very simple. That's going to be 31 by 50, 32 by 50, 33 by 50, dot 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 dot. That will go till 39 by 50. Okay, so these are all the rational numbers that lies between 30 by 50 and 40 by 50, and I think we have to pick out how many. We have to pick out 5 rational numbers. So you can pick out any 5 rational numbers from this, and that will be your answer. So question number 2 and question number 3 are kind of exactly the same. Now let's go to the next question. I think that's the last question. Yes, we have to state whether the following statements are true or false. Give reasons for your answers. So we have 3 statements based on natural number, integer, whole number, and we have to state whether they are true or false. So let's see how that can be done. First, let's get rid of this. Yes. Okay. Now, statement number 1 reads, every natural number is a whole number. So very quickly, first let's make a number line representation of natural numbers. So this is natural numbers. They are represented like this. Okay, it starts from 1, 2, 3, dot dot dot, and there is arrow here which indicates infinite. And then let's list on whole numbers. So whole numbers, it just includes 0, rest all is same. So 0, 1, 2, 3, and dot dot dot. Okay, now let's reread our statement. Every natural number, so every natural number on this number line is a whole number, So take any number on this number line. This is a set of natural numbers. Is it present in this whole number line? Yes, because from 1 all the numbers are included in this number line. So this statement that every natural number is a whole number is absolutely true. So I'm going to mark here true. Okay. Next, every integer is a whole number. So we haven't mentioned integer number line. So let's do that as well. This is my integer. So integer number line is a bit big. Okay. So let's just, okay. And now this consists of, let's say, -3, then -2, then -1, then there is 0 here, and then we have 1, and we have 2, and we have 3. Okay, so this is our integer number line here, and yes, the dots are very important. This is infinite, dot 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 dot. Now let's read the statement again. Every integer, so every integer is a whole number, We can clearly see this is a false statement because these integers are not represented here in the whole number line. These negatives are missing. So 1 1 as an integer is a whole number, 2 as an integer is a whole number, but they are saying every integer. So if I take -3, then -3 is not a whole number. So this statement becomes false. So I'm going to mark here false. Now last statement is every rational number is a whole number. So we haven't noted down rational numbers here. So let's do that quickly. So rational numbers do not have any specific representation as a number line, but they are represented in the form of P by Q, okay, where we know that P is any integer, okay, and Q is also any integer except 0. So I'm going to make a note of that, except 0. Okay, so now let's read the third statement. Every rational number, so every rational number of the form P by Q is a whole number. This is clearly false because let's take 1 by 2. 1 by 2, is it a valid rational number? Yes. And is 1 by 2 present in this whole number line? No. We just have 1 and we have 2 and we have 3. In between 1 and 2, nothing is mentioned. So every rational number is a whole number? No. That's a false statement. So I'm going to mark it as false. So this also becomes false. Thus, we have completed this question number 4 as well. These 4 statements are marked true, false, and false. This is the completion of exercise 1.1 from chapter number 1, number systems.